Game Theory Class 7 Video 3. In this video we're going to talk more about the rational outcome of a game. If you recall from the previous video, we said that if both players have a strictly dominant strategy, then that is the rational outcome. So for example, if A is a strictly dominant strategy for player 1 and X is a strictly dominant strategy for player 2, then AX is the rational outcome. Well, in this video we're going to examine what happens when there aren't two strictly dominant strategies. So maybe player 1 has a strictly dominant strategy but player 2 doesn't. And can we still talk about the rational outcome in these cases? So let's begin. So in particular, what I said was, if only one player has a strictly dominant strategy, then we can still predict the rational outcomes. Okay, and it works like this. So here's a theorem which will help. It says, if A is a strictly dominant strategy for player 1, then the rational outcomes are A, the best response for player 2 if player 1 plays A. Okay, and notice now it's not a mistake that there's an S and this isn't an is. Like, sometimes there's more than one rational outcome. Sometimes there's one, sometimes there's more than one, sometimes there's none. Okay, and that's okay, and it's because the best response function sometimes gives you more than one answer. Okay, so why does this theorem make sense? Why is it a reasonable theorem? Well, let's think about it. Like, imagine you're player 2 and you're perfectly rational, you're perfectly logical and mathematical, and you know that player 1 has a dominant strategy. You know that player 1 has a strictly dominant strategy. Okay, well, because you're perfectly logical, you deduce that that means that player 1 is going to play that strategy. Okay, you know that player 1 has a strictly dominant strategy and you know that they're going to play it. So then what's the best thing you can do? Well, by definition, the best thing you can do if player 1 plays that strategy is this function right here, right? The best response for player 2 if player 1 plays A. This is the best thing you could possibly do if player 1 plays A. So this is the rational outcome of the game. So let's take a look at some examples. Okay, so here's a game, and the question is just find the rational outcome, or outcomes if there is more than one. Okay, well, the first thing we need to do is work out, are there any strictly dominant strategies? So if I compare A and B, first of all, I see 1 is bigger than 0 and 0 is bigger than -1. In fact, they're strictly bigger. So this means that A is a strictly dominant strategy. Okay, so that means that player 1 is going to play A. So player 1 will play A. Okay, and I guess we can examine player 2 strategies now. So if we look at X and Y, we see 1 is strictly bigger than 0, but 0 is strictly less than 9. So this isn't consistent, right? This means that player 2 doesn't have a strictly dominant strategy. Okay, but player 2 is still a rational person, and player 2 knows that player 1 has a strictly dominant strategy. So that means player 2 is going to do the best thing they can with that information. So the rational outcome is going to be A, the best response for player 2, given that player 1 plays A. So if we assume that player 1 plays A, what's the best thing that player 2 can do? Well, if they play X, they get 1 point. If they play Y, they get 0 points. So that seems like X is the best thing for them to do. So the best response, so the rational outcome is AX in this case. And that's the end of this example. Let's do one more example, maybe a slightly harder example. Okay, same question. Find the rational outcomes. Okay, and I will skip ahead a little bit, and I will tell you that B is a strictly dominant strategy. Okay, you can see this because B is strictly better than A, and it's strictly better than C. B beats both A and C, strictly better than both of them. Okay, so this means that player 1 will play B. And now if we examine player 2, if you try and work it out, you'll see that player 2 doesn't have a strictly dominant strategy. Okay, but that doesn't mean we can't work out the rational outcome. The rational outcome is going to be, we know that player 1 is going to choose B, and player 2, being rational, is going to do the best response to player 1 choosing B. So if we think about what that could be, we isolate the B row. If player 2 chooses X, they get 3. If they choose Y, they get -2. If they choose Z, they get 3. So the best response in this case isn't unique. There's two of them. It's BX and BZ, because they both equally they're equally the best response for player 2. So the rational outcome is BX and BZ. There's more than one rational outcome, but that's okay. Okay, so that's the end of this example. Before I finish, I just want to reiterate one fact about rational outcomes, and it's very important. It's this idea that everywhere I've been writing the word strictly. Okay, you can't talk about rational outcome with weak dominance. It's essential that it's a strictly dominant strategy. If it's just a weakly dominant strategy, then you can't talk about this rational outcome.